Limits are really important and interesting with a lot of applications, but physics 101, it's not functions and limits, it's functions and differentiation. Limits are crucial though to actually define what a derivative is, and this is what we're going to be focusing on right now. This is for section 4, derivatives from first principles. To motivate what we actually want to do, let's start simple. Say you have this straight line and you want to calculate the tangent line at a specific point. For a straight line, this is actually quite easy because the tangent, which is the slope of the curve at that point, let's call this point P, is simply calculated by any offset in y divided by an offset in x. So let's say that this is x and you give it some offset delta x, this will correspond to some point y, and this quantity is delta y. So the tangent line is very simply given by delta y over delta x. And this, because it is a straight line, this is true for any x really. And it means that the slope of this, the rate of change of the function, is the same everywhere. In order to make things easier and more explicit, what we typically look at is the value of the function at the final part of the displacement, for example yf minus yi, and the same, the corresponding displacements in x. But sometimes we also use y2 minus y1, x2 minus x1. In this case, this would be, for example, x1, and this point would be x2, this would be y1, this would be y2. This is just to make sure that everyone's on board with the notation that we're going to work when we move from tangent lines of just straight lines, it's pretty easy, to a general curve. And our goal is really to find a general equation to find tangents to any curves. So this is the goal that we're going to work towards. This is what we call derivatives from first principles, and this will involve limits.